All right, last section. So 12.4 is probability of what's called disjoint and overlapping events. Okay, so again, probability, what you want to have happen or everything that could happen. So let's look at a couple of different scenarios that will happen. So a card is selected from a deck of 52 playing cards. What is the probability it will be a 10 or a face card? Okay, so we have two different, one card's going to get picked, but we have two different situations. So we'd have like the A situation, which would be the 10, and we'd have the B situation, which would be a face card. Okay, and so for the A part, well, there are 4 10s out of 52 cards. For the B part, a face card, that's Jack, Queen, King. So there's 4 jacks, 4 queens, and 4 kings. So that would be 12 out of 52. Okay, so in this example, so this is what's called a disjointed example, because in A, there's 4 10s, and in B, there's 4 jacks, queens, and kings. They don't have anything that's what's called overlapping. The 10s are in A, the face cards are in B. You can't have a 10 that's a face card or a face card that's a 10. They don't like what's called overlap. So when they're separate like this, you just add them together. And then you would still want to do 16 divided by 52. And so it's 30.8%. Okay, so disjointed, they don't have anything in common, the A and the B part. Okay, so if they don't have anything in common, you just add them together, whatever the probability is. Okay, disjointed. If they do the same situation, with cards, what's the probability that we get a face card or a spade? So the A situation is face card, and the B situation is a spade. So in the A situation, again, there's 4 jacks, 4 queens, 4 kings, or 12 cards out of the 52. In the B situation, there are 13 spades. Ace, 2, 3, 4, 5, 6, 7, 8, 9, 10, Jack, Queen, King. Okay. So we're still going to add those together. However, there's an overlap in this one. So we have a jack that is both a face card and a spade. We have a queen that is both, and we have a king that is both. So we can't count them both in the 12 and in the 13. So we have to, there's 3 of them that do that, so we have to take away 3 things because they'd be counted twice. So the subtraction takes into account that they're only counted once. Okay, so 12 plus 13 is 15. 15 minus 3 excuse me. Sorry, 12 and 13 is 25. I think I said 15. 25. 25 minus 3 is 22 out of 52. And then again, we want to divide that. And we get 42.3%. Okay, so it'd be kind of like, I think one of the problems on your assignment talks about rolling like a die. So it'd be like saying like, what's the probability? I'll do one. So anything in common are overlapping where they have something in common. You're still going to add it together, but then you have to subtract the part that overlaps. Okay, so it looks like your first 1, 2, 3, 4, 5 problems are disjointed. And then I think the next 1, 2, 3, 4, 5, 6, 7 are overlapping. The last 2 you get 1 of each. So it's about half and half. Okay? So just the big thing to remember is if they don't have anything in common, just add them. If they do have something in common, you still add them, but subtract the part that they have in common so you don't count that thing twice. All right, so that's it for today. We'll do just a little bit more of this tomorrow, and then we'll start reviewing for your test on Friday. Have a good day, guys. So if we roll a die, probability of an even number or a number greater than 4. So again, the A part is even and the B part is greater than 4. So it's easier to kind of list them out in this one. The even numbers, so I'd get 2, 4, or 6. So there's 3 of them out of 6 total. The B part, greater than 4, would be 5 and 6, or 2 out of 6. Okay, but we have a 6 in both of them. So I can't count that twice, so I need to subtract. There's one thing that's there in both, so I would subtract the 1. 3 plus 2 is 5, minus 1 is 4 out of 6, or 66.7%. Okay, so those last 2 are considered overlapping probability. It's because, again, they have events that are used in, or values that are used in both situations. Okay, so your first couple problems will be just with disjointed, where they don't have